Welcome to episode 4 of our podcast, Innovating the Industrial World. I'm John King, your host, and we're here to talk about collaborative robots today. And I'm here with Mike and Manan in our automation group. And Mike and Manan, you want to introduce yourselves to the listeners?
Yeah, sure. So I'm Mike Holland. I've been in the industry for about 34 years, and I've been with Cross for about 10 of those.
I'm Manan Banerjee. I've been in the industry for 11 years now. I've been with Cross for 5, and I've been elbows deep in collaborative robots for about 6 of those years now.
That's awesome.
Yeah.
Okay, cool. So when we talk about collaborative robots, like we talk about cobots, collaborative robots, what is a cobot? What is a cobot, and what are some of the other types of robot technologies out there?
Yeah. So cobots, the name is not very cryptic. Cobots, that's collaborative robots. We refer to them internally, we call them cobots, right? But it's a collaborative robot. And what does that mean? Just that. It's collaborative. It can work hand in hand with a human. Unlike industrials, which require tons of guarding, take up a lot of space, they're dangerous to humans if you get in that space. They've really created a lot of buzz in the industrial world since they came into the marketplace in the U.S. about 12 years ago.
So those big robotic welders with the sparks flying everywhere behind big cages, those are industrial robots, right?
Yes.
And then what we talk about, cobots work hand in hand with people.
Mm-hmm. Yeah. I think one of the important things, too, to keep in mind is that you look at what any particular robotic arm was designed for, right? Certainly you can make an industrial robot as safe as possible, but fundamentally it's designed to outperform what a person can do, right? It's way beyond human capability. You have, industrial robots that are, even if they're picking up only 5 or 10 pounds, they're whizzing from point A to point B. And then like the bigger robots, they'll pick up 200 pounds and move it faster than you can imagine, right? Collaborative robots, really the successful ones that see a lot of widespread use, those are designed from the ground up not to be superhuman in their capabilities. So what does that mean? It can only pick up so many pounds. It can only move so fast. That seems like a handicap, but that kind of is the reason why they are able to safely deploy next to people. You don't want something superhuman. You don't want Superman working next to you in the assembly line, right? He makes one bad move and that's you're out.
Yeah, exactly.
So that's one of the key things I think to keep in mind.
Yeah.
That's awesome.
Yeah.
So cobots are really gaining in popularity quite a bit. Now the technology has been around for a while, maybe 10 years or so. Why are they gaining in popularity so much?
I think there's a couple of reasons. So not the least of which is the labor market that we're in now, right? It's very difficult to have people doing, especially manual tasks, right? Yeah. The dull, dirty, dangerous things that we think about. Number one, it's hard to fill them, and it's harder to keep them in that position, right? So I think the industrial world is just really ready and more accepting of that because they don't have the people available to do those jobs, right? And it's critical to their business.
Yeah.
Yeah. There's some other things that come into play also. So the U.S. has been, of the industrialized countries, the U.S. has been somewhat slower to adopt robotics. We've had the traditional automation and we've led the world in traditional automation for years. But with robotics, we lag behind Asia and Europe significantly. And that's starting to change. And a lot of that change is brought on by the advancements in safety with robotics, as well as the more install base you have, the more acceptance there is. There's a better baseline of history, right?
Yeah.
And so it makes it a lot more of a viable option for folks.
And like Manan talked about, with being able to pick up, so move more around, more like a human, means that you can work alongside and makes it a little easier for that.
Yeah,
acceptance.
if you look at a collaborative robot, cobot, a lot of times what you'll see with not only the payload, the speed, the reach, those are all very similar to what a human does. So they're designed to work not just with humans, but at that human speed, right?
Right.
So, yeah.
That makes a lot of sense. So what are the best kind of, when you mentioned dull, dirty, and dangerous, what are the dull, dirty, and dangerous jobs or the dull, dirty, and dangerous activities and things that we can do with a cobot?
Machine tending is one of the I guess, the front runners when people think about robots automating dull, dirty, dangerous, unfulfilling tasks that people are capable. People are really good at it, but just no one wants to sit there loading and unloading parts, right?
Same place every time.
Same place every time. There's a lot of different verticals and application categories. Pick and place tends to be one of the most dull. It can be dirty and dangerous too, but like there's a lot of really dull, simple jobs out there. I say simple, that's probably not a good thing to say, but dull jobs for sure. Repetitive, doesn't require the things that people are really good at, right? Critical thinking, problem solving. People don't like to do those jobs.
But a cobot's great at.
A cobot, any robot in particular is perfect for that. A cobot is good. While we're talking about, Mike, you talked about the major economic factors that are driving robotic implementation, right? Mm-hmm. One of the microeconomic things that are driving cobot specifically is that job shops are really hard to automate. Mm-hmm. Our job shop environments are really hard to put automation into because with traditional automation, whether that's a robot or a gantry or whatever, the safety is a big investment. It's a big portion of that investment, right? And if you have this big industrial robot, more than likely it's not going to move. You put it on one machine and you can run that robot when that machine's running, right? All good. Except in a job shop environment, you might not be running that machine every day. Mm-hmm. So if you look at return on investment, it gets really fuzzy, especially from a utilization standpoint. You might not be using that machine all the time for high mix, low volume environments. All of a sudden, if you don't need to put up all that guarding and have everything fixed in place and you can move your pick and place system from machine to machine, it becomes much more compelling. And I think that's driven a lot of adoption for cobot technology as well.
Yeah, I think so. It makes really good sense because, one, they're a little bit more versatile. Like you said, you don't have to put all the safety equipment and everything else and tie it all down. You can move these things around. But one of the other things is, you mentioned pick and place and doing the same thing over and over again. Yep. Something very similar to that is we talk about palletizing and packing and palletizing. Absolutely. So sure. Right now, goods are moving all around incredibly quickly. Yeah. There's tremendous amount of distribution centers, Amazon, all those things in terms of online purchases. You have pallets of boxes and equipment and parts coming into a facility, need to be unpacked. We need to do something to them and then pack them again. So is that something that collaborative robots are pretty good at?
Yeah, absolutely. Those areas in a production plant tend to be fairly crowded, especially at the end of line where pallets are going on. You have a ton of traffic. Oh yeah. We've looked at a lot of palletizing applications. A lot of times they do need guarding, but man, is it nice to not have to require guarding, right? Mm-hmm. While we're talking about this, while I said have to require guarding, at the end of the day, the robot is a big piece of the safety puzzle, right? I'm looking at the camera a little bit because I'm talking to anyone that's getting light bulbs going off and just kind of tempering things a little bit. The robot is a big part of the safety puzzle. If you have a robot that inherently out of the box can injure or kill a person, that's one scenario. This robot out of the box has a lot less risk of doing that, right? And note that I say less risk. If you're out there watching this and you think, that robot's collaborative, great, I'm going to put a chainsaw or a flamethrower on the end of it. Just stop, right? Right. When we say collaborative robot, the robot is a piece of the puzzle. At the end of the day, it's going to be your application that's collaborative. And you need to look at the sum of all the parts, so to speak.
Right, but there's safety standards designed into collaborative robots and cobots to make sure that if it does encounter a person, if it happens to hit something or whatever, it will stop, right? Sure.
Yeah, the robot is really, really good. If you take it out of the box and you just have the robot arm moving around and someone approaches it, great, perfect. Safe. There is no application on Earth that just involves a robot with nothing on the end of the arm, right? Yeah. So that's why anytime I'm talking about this, that's why I look directly at the camera. I make sure to say it's your application at the end of the day that's collaborative.
Yeah, that's correct. Yeah. You talk about the best applications for it, right? So we call it AMP, automating manual processes here, right? And so what does that mean? So if you go into a discrete manufacturing plant, you look and you see a large production line that may be 100, 200 feet long, where they have raw materials coming in at different points all through, and they get finished goods out the end. Where we look at on that highly technical, very expensive, productive piece of equipment is where pockets of people are interacting. And they're truly not adding value. They're moving things around. They're picking this up, putting it here. They're taking this, they're loading it in. They're taking it out, they're putting it in a box. They're taking a box, putting it on a pallet. And so those are really inefficient, and they're jobs that people don't like. Humans do not like those typically, right? And so it's uniquely suited for a collaborative robot. That's what they were built for. And it seems like such a simple thing. And for me, because we've been doing it so long, I'm amazed that everybody doesn't have one in every manufacturing site, right? Because the ROI, and we'll talk about that later, the ROI on these, it's incredible. I've never seen one have a bad day. I've never seen one call in sick. I've never seen one have an argument with its boss, right? And a great thing that you get from the implementation of a collaborative robot in your production facility is, let's say you have 7 people and you're fortunate enough that you can fill all those positions, and you have 7 people either doing some kind of a manual pack, a manual fill, a manual load, a manual unload, all of that, right? So when you put a collaborative robot, you don't have to replace all 7, or you don't have to repurpose and let them do more meaningful work where they can reason and process. You can put one collaborative robot in there, and it's an amazing thing. What happens is that robot now becomes your pace setter. So you're going to get this really nice uptick in productivity, only because you've got something there that always works at the same pace, always works with the same spot, with the same precision that it's dropping or moving or loading. And it actually creates a better workflow for your entire process.
It makes really good. But you had talked a lot about how, when you take them out of the box, you can make them do this and that and the other thing. But one of the things that we talk all the time about is that it's not quite as easy as that, is it? Like you can't exactly just take it out of the box and make it pallet, take boxes off of a pallet or put them onto a pallet, right? Yeah.
And if there's one thing that I've ever taken issue with the rise of cobots over the last 5 years, there was a picture painted that anyone can.
It's this promise of simplicity that's really, exactly.
And certainly, one of the things about designing a robotic system from the ground up to be, a certain way, is that a lot of people went and designed a teach pendant and a user interface that was very, very accessible. Certainly, anyone watching, I challenge you, go look at a industrial Google, image search this. Look at a picture of a teach pendant on Google image search for an industrial robot. And if you haven't been trained on it, I challenge you to tell me what would be the first button you press. It's extremely intimidating, right?
Unless there's a help.
And it's not intentional, right? No one sets out to say, I'm going to make the most complicated looking thing I'll ever hold in my hand. Just to confuse people, but there's, decades worth of legacy stuff on that pendant. While you're designing a new robot from the ground up, why not make the interface cleaner, simpler, easier to understand? So that's what a lot of people did. And it is true that most people can look at a teach pendant or the interface on a cobot or some certain cobots. And make sense of what's going on. I've done dozens and dozens of demos at customer sites, and I'll specifically look for the person in the room that's could be the secretary, it could be someone from their EHS group that's never programmed anything, and I look for that person and get the teach pendant in their hand and show how easy it is. I'll have that person do a simple pick and place, right? Is that who you want programming a production application? No, almost never, because making sense of the teach pendant is one thing. There's also, what are best practices in production, right? Do they have some kind of programming background? You still need that logical, the logical component of programming something. There is some experience there, right? You're probably going to need to make the robot talk with some other piece of machinery. It's inevitable, right? There's only so much you can do with just the robot on its own, not communicating, keeping pace with anything else. And of course, the safety. You'll see right now that robot has a little red ring light. That is because there's area scanners on that unit that can tell the robot, hey, there's someone up close, right? Area scanners, that seems really easy. Area scanners can't tell the difference between a person and, for example, that wall that's, maybe 8 inches away from the area scanner. Right. There's a lot of considerations that go into deploying a collaborative robot beyond just what buttons do I hit on the teach pendant.
And what are some of the other complexities we've run into? So, for instance, a collaborative robot or a cobot to pick something up and put it down in the exact same place, so that I'm always picking it up from the same spot and always putting it in the same spot. Yeah. That is that sort of simple system that you talked about. But the real world is not that simple, is it? So what are some of the things that we've run into that make it much, much more complicated? It's just not as easy as it looks.
Yeah, so Manan said earlier about, you're going to interface this robot with something. Just the robot sitting there. It looks great and it's fun to play with, but it's not a very efficient tool, right? So once you get the end of arm tool, you get the fingers, what you're touching the part with. It's so important to think about the entire process, not just what this robot's moving, right? Mm-hmm. It almost amounts to a checker game if you think about it, But there is so much more involved. And the biggest piece of that is in-feed, out-feed. How are you presenting the parts and how are you accurately removing the parts and placing them, right? Mm-hmm. Is there an inspection that has to be done? There's all kinds of things. So I think it's not untrue that collaborative robots are much easier to program. They absolutely are. They're much more intuitive. The programs are written such that if you can work an iPhone or a tablet, you're able to maneuver within it. Does that negate your necessity for having to know, understand, and really be a controls engineer to get this done, as well as a mechanical designer to get everything that interfaces with that part correct, right? So that's the biggest thing for me when we talk to folks about a collaborative application. And like Manan has mentioned Job Shop several times, right? Yeah. And we do a lot of work with those folks because it's a great fit for a collaborative robot. And you'll ask a question, okay, how long do you want to run lights out? And that's what we call totally unassisted, right? You have the parts available, located, known positions, and you have the once they're completed, where do they go? But you have to have enough space or enough automation to feed, unload, to support that. And so we get lots of times we'll get folks that say, okay, I want to run 12 hours, for example. Mm-hmm. Okay, what's your op time in your machine? And they'll say, oh, it's 45 seconds. They're not thinking, and this is maybe a small, like a VF4 or something, just a small CNC machine. And what they don't see in their mind when they say, I want this to run for 12 hours, is if their part is 6x6 and weighs 3-4 pounds, for example, think of the space that if you're getting one out every 30 seconds, where are you putting them? Right. How are you getting them in? How are you getting them out? And that's the part where you really need to talk to an automation expert or have those on staff.
I'd say, so even the engineers downstairs that program robots, mm-hmm. At any given time, we have at least one project with a robot going on. And I'll tell you almost without fail, at least 60 to 70% of our time on all those projects goes to how does the robot know where the parts are? Mm-hmm. I'm not kidding. It takes so much effort. And anyone out there that writes code or anything, you know that writing your main program is the easy part. That takes almost no time. Even the most complex programs, out of the total amount of time you're going to spend on it, mm-hmm. writing your main program is that much of it. The other 80% is all the stuff you didn't think about, right? Yeah. How do you, in the case of a robot, it's how do you make sure the robot knows where all the parts are? What's your error handling look like? What's your recovery look like? Mm-hmm. You're not even going to know what errors you're going to run into, right?
Because to make it go to just a XYZ coordinate and do something, you can do that. But the problem is when you go there, it's not exactly the same way every time, right? So you're having to, how am I going to pick it up? How do I know that something's moved a little bit? Or how do
You're over time. I think a critical part of that learning process is to get burned really badly by your own assumptions at least a couple of times. That's honestly what it takes.
And forgive the interruption, but I'll add to that saying that as long as we've been doing this, we still get a surprise every now and then, right? And so we call that our gotcha. We'll find a gotcha, something that we did our absolute best, did our due diligence going into it, pulled all the information we thought we could, and then something will pop up and say, yeah, no, you're not quite there yet.
So what are some examples of
I was going to say, So a big thing that we are all very conscious of now, especially is like supplier vendor dunnage coming in, right? So a lot of folks, it is obviously the most economical, the most efficient if you can use your supplier's dunnage as a way to locate and bring your parts in for the in-feed, right? That's obviously, you don't have to handle them twice, all of that. And we have gotten samples from these wonderful vendors who are just so consistent every time, right? And so we'll get this incredibly neat stack of parts. The dunnage is perfect. They're all laid out. They're located really well. Maybe just a little vision assist. We can get those things. We can identify them, get the coordinates, pick them up reliably. And then we get another box, another container, and they're completely different, right? We've had that bite us so many times, and it's just an inconsistency from your vendor. So those are critical things that it may or may not be within your control that you really have to either overcome through other means of automation. We've had to just jump through flaming hoops to get things done, You can do it, you can overcome it that way, or the most unlikely and the least resolved is you can talk to your vendor and they'll modify the containers, the package, the dunnage that goes in it. That's rare. You have to be a fairly large consumer of those to be able to get things like that. But you're not left with a lot of options. And so it's amazing to me how, even with all the experience that we have, that we still, like I said, we'll find a gotcha. And fortunately now we've got a great library of expertise and enough bruises and scars that we can motor through those pretty quickly.
We've sort of dealt with that. We have some automation engineers that we run into and factories all over the place that will, they hadn't dealt with that.
Right.
And it's just not quite as simple as it looks. What are some of the ways that we've been able to deal with that? So we talk a little bit about palletizing, which would be one of the more simple things. So let's just talk a little bit about what are the complexities with that particular thing. It seems easy. You've got, that is exactly a sort of a dull, dirty, and dangerous job of taking stuff off of a pallet and putting it on. How do we deal with that?
By asking a lot of questions. And one of the main things that we found is the consistency. All right, let me back up. In a palletizing cell, that's happening at the very end of your line. Right? If you think about how the boxes get to where they're palletized, what's happening right before that is probably there's some kind of conveyor, and there's probably a machine that the boxes go through that fold the top flaps down and tape them. That we call that a case taper. The consistency of that case taper that'll have a huge impact on the project. There are definitely things that we can do to get around that. But number one, it's going to be more complicated, right? For a palletizing cell, you're adding complexity there to compensate for things happening upstream that aren't ideal. And number two, it introduces another variable into the system. And one of the biggest challenges with palletizing that is easy to kind of gloss over is the number of variables that there are. The more variables you have in a system, the more of a potential headache it could be. I say headache, but it's just problem solving, right? Just things that to account for. In machine tending, your part most often is the only variable. And can you actually pick it up with the robot? Cycle time, all that stuff. It's there, but it doesn't swing as wildly. In palletizing, you have nobody ever palletizes just one. We have one customer that ever in the last 5 years that said, we run this one box, same weight, same pattern every time. It'll never change. And we're like, wow, it's one time out of dozens and dozens of applications we've looked at. But what normally changes is, people have dozens of different SKUs with stock keeping unit. It's how we identify like what their product is coming down the line, right? What's the size of that box? What's the weight of that box? How is that box going to be oriented? How does it need to be oriented on the pallet? How good are your pallets? Every once in a while, we run into a customer that has, fresh, clean pallets. More often than not, the reality is your pallets are going to be just not in the best shape, right? They've been making dozens of trips.
Cycled a few times.
Missing slats, whatever. What size is your pallet? How does that relate to the robot reach? Okay, well, now I have all these different boxes, right? The smaller the box, the more your robot has to reach to get to the far side of the pallet. But how high is your stack? Is it going to be shrink wrapped? Are there slip sheets? Where do you put the slip sheets? What's your cycle time per box? So with palletizing, there's so many variables. It takes a lot of homework up front to put one robot in there that'll handle
it. Does. What I think is really interesting is that this entire industry for the longest time has been saying, okay, the things that we want to automate with a cobot need to be repetitive things, repetitive activities. It could be argued that the most repetitive things need to be around the cobot, need to be how things come, the fact that it's consistent every time, removing some of those variables, as you mentioned, to make sure that not only that the job's repetitive, but that the things around it are repetitive parts, making sure it's the same box, the same pallet every time.
It's the same requirements as in a pick and place, right? It's all about part placement, right? So that we have a good in-feed with an absolute known location, a known position of the part, what the part is. Every application with a robot requires that, be it pick and place for just loading or loading a screw into a press, for example, or palletizing or machine tending. It's all the same. It all comes down to where is a repeatable, reliable place that I can pick a known part in a known location, get it to somewhere that value's being added, and then returning it to where it can go out and I can just complete the process all over again until we're done. So they all share these common things, but the big message for me in collaborative robots and what it took me a bit to understand is when these things came in, they were so disruptive. Everybody wanted to see one, everybody wanted to have one, but nobody knew what to do with them, And so as that's evolved, we've all figured out, now understand, know, and embrace this technology because it really does have a really just incredible place in manufacturing. And that's to understand that this is really, don't think of this like your traditional robots and we're going to be screaming, running, doing all this. This actually, it's designed and built to work with a human at a human speed, at a human weight, right? Yeah. And so that makes it just an absolute great choice when you have these manual processes that you're unable to fill the personnel. You can't get the people in there. It's incredible.
So you mentioned a while ago about ROI and that this promise of a collaborative robot can be incredibly helpful. How do we help and how do we figure out, is it worth the investment? Is it all this complexity? Can we make it work? And how do we know if it's worth the investment?
Yeah. So, most folks in industry, most plants, most companies, they have their internal triggers for what makes a viable project, right? If the ROI, the return on investment, typically it's 2 years or less, right? Yeah. But it can get a little more tight than that. So what we always do, one of the first things that we do, it's part of our discovery process, and that helps us as much or more than it helps the customer, because when we do the ROI calculation, we know before we really start doing any investment internally, and we can work with collaboratively with the customer. I just lost my train of thought. So there.
That's all right.
Yeah.
But we can figure out.
Yes.
So what we can do is take, okay, what is the cost of having people do this?
Mm-hmm.
And people is not just hours, right? So there's an hourly wage associated with that,
Right.
but there's also turnover. There's training.
Mm-hmm.
There is multiple shifts. There's other things that go into that. So we've talked about how complicated it is, which, that may require a little bit more investment to decomplicate that to make it work.
Right.
But we're comparing that to what it costs to have a person do that, and also what it costs us to employ a person to do that, which is more than just the person, right?
Mm-hmm. Sure.
So how do we, what are some of the examples we've had where we've had a great payback, where it really has made good sense?
So one of the best examples, and it was, I'm going to go back to our ROI calculator, right? So I worked with a lot of ROI calculators, and I'll embarrass John a bit. John was very involved in creating this with another guy who likes spreadsheets just as much. And so they have created this incredible, I think, ROI calculator. It works really well. And we look at, is it going to increase productivity? Is it going to increase quality? Is it going to reduce risk by eliminating a safety issue? All these things go into this. And it's very specific questions, and it'll point us to the right direction, or in the right direction, and give us a great quantified number of what it's going to cost and how long the payback is, right? And typically for a cobot, for us, what we find is that the payback is typically less than a year in a lot of applications.
That's pretty awesome. What's the best one you've run across?
From an ROI standpoint?
Yeah, that you can remember.
There's been a lot of good ones in general. Smaller manufacturers running multiple shifts.
Yeah.
That tends to be a pretty good scenario where they see some payback. Yeah. Especially, think about, this is a little bit more technical, but the robot, when we're looking at an application, right, the first two questions, almost always, before anything else, how much do your parts weigh and what's your cycle time? Mm-hmm. And those two things drive almost everything else. Yeah. That is the starting point, right? So if you're thinking about smaller parts that don't weigh a whole ton, that means you can cram more of them in a smaller space. So with the same amount of reach, you have access to more parts. And you could, especially for like a machine tending scenario or like a process tending where the robot can pick up multiple parts while it's waiting on that process. It can have another one kind of primed right there and then just do a quick swap instead of making another trip. That kind of scenario lets you put more parts to the robot. And the more, which equates to the robot running for longer before a person needs to come up and reload or mess with it at all. And that's where you tend to get, the more parts you can get to the robot, the more ROI, or the better ROI you get out of it. Because remember, the robot's not designed to go super, super fast.
Right.
So typically we're not after making more parts in a shorter amount of time, but the longer the robot can run on its own, you've surpassed the throughput of a person
and get a whole lot better return on that investment. That's pretty
got
awesome.
a great example of ROI.
Okay.
And how it took a project that a particular customer, the internal engineering group, the production group, did not think it was a viable project until their management team was able to look at the ROI, and absolutely we were going to do it. And it's a pretty cool story. So it's a large company, and they had a manual process where they were curing parts. Yeah. And they were doing this manually, right? And so they had to do some assembly. There was some epoxy involved. These parts have to cure for 5-6 minutes, whatever. And so they were doing all these, they were doing in very small batches, right? So you would have 8, 9, 10 operators, and they would have a batch where they could do like 8 at a time. And so if you think about that type of production, it's very inefficient, right? So if you just think about that, they're doing 8 at a time. Well, when they take this fixture out that they're going to place these in to put them in the curing oven, they put the first one in. It takes 1.5 minutes to do it, basically, to get this thing together, to get it ready to put in here to be cured. Well, it's ready to go, but it can't go because it's got 7 more to be put in there, right? So instead of your cycle time being 1.5 minutes and your heat being able to keep up with this, then now your cycle time is 1.5 minutes times 8. And then you've got the curing time where you're doing nothing, right? And so we were able to automate this so that it truly was a 1-for-1. We can cycle them through as soon as they can present them to the machine in like a minute assembly. And it took their time from, we increased their throughput by 130%.
That's amazing.
130%. The best thing about this was we not only increased their throughput by 130%, but it was for a sold out market, this particular product. They had a 4-month backlog, and business just keeps coming over the
So every one of those 130% means that they could sell it.
That's revenue.
That's revenue.
Yes, sir.
Printing
That's
money
awesome.
at that point.
Yes, sir.
Yeah.
It was like an ATM machine.
That's awesome. Okay. So yes, they are more complicated than they look. This, you mentioned before about the industry, sort of the promise is a little bit different than the practice, but once you figure it out, the return on that investment can be astounding.
Absolutely.
That's
Absolutely.
awesome. Well, that kind of wraps it up for episode 4 of Innovating the Industrial World, talking all about collaborative robots. If you like, and you'd like to geek out with us a little bit more, then go to crosscode.com, get a little bit more information. If you have any questions or comments, please put them in the comment section below. And if you like what you've heard, like and subscribe, because hopefully you'll hear when we have the next episode. Thanks so much.
Thank you.
Mike, Manan, thank you.
Yeah.